Good afternoon, everyone. Welcome. I'm really impressed with the size of the attendance today. This event is co-sponsored by the Harvard Data Science Initiative, Institute for Applied Computational Science, Institute for Quantitative Social Science, and the Center for Geographic Analysis. We're fortunate today to have Dr. Alex Liu as our speaker. Dr. Liu is the chief data scientist at IBM, and he is one of the thought leaders in the field of data science and the chief data officer training program. He's in charge of the initiative for bringing AI to social science and business research. Before joining IBM in 2013, Dr. Liu worked as a chief data scientist for a number of other companies, including iSky and Retention Science. He had also taught advanced quantitative methods to PhD students at University of Southern California and UC Irvine. He also did consulting for many organizations, including the United Nations and others. He has a Master of Science in Statistical Computing and a PhD in sociology from Stanford University. With that, Dr. Liu.
Thank you, Wendy. Yeah, good afternoon. I'm very and honored and also really impressed. And I just flew in from Los Angeles yesterday, and the warm weather there. With the cold water and the weather here, I thought that maybe I will meet 10 people and then have a informal talk. I didn't expect this, but really and impressed. I guess the main reason is that data science, AI, is really a hot topic and also very challenging topic. So when I initially talked with Wendy about what to speak today, originally I thought maybe I should prepare at Harvard. I must be prepared the most intriguing and the challenge algorithm to present. Then I thought, but again, then I think I will take a different approach today, and mainly because in this field, everything changed so fast. And for example, when I start working for IBM, and I, besides working with many big clients of IBM, like banks, corporations, I also participating in some of the technology work. And so I observe even within IBM for the last 6 years I have been there, everything changed so fast. At the beginning, I worked with what when IBM called the Big Insight, a platform to access and a huge amount of data through Hadoop, and later Spark, then turn that into something easily to be handled by other tools. And then quickly it got changed. Now another platform emerged called Data Science Workbench, and which is kind of extended then to include other tools and help people to put any person you have all the tool package is like a tool package carry. You have everything you need. Then quickly, then the demand and the industry feedback pushed to change it again. Then IBM have another platform called Data Science Experience. I don't know any one of you try that. Quickly, it changed to Watson. Now it's called IBM Watson Studio. Have more stuff because AI is what people ask for. So in this field, really, it's like everything is kind of changed so fast. It's very hard to anticipate what's coming even tomorrow. So in that way, I will prefer to that to share with you and my journey, and if I have time, even I can even cover some of my. I don't want to see success story. I prefer like failing stories, and most time you actually learn more from your and failures than your success, because when it's you, especially for me, like working with IBM and other place, we kind of try to solve real problems, and with the in the real world, and the data is not perfect and your team is not perfect, so most time and the successful ratio is very very low. If you if you become successful, sometimes because you're lucky, or sometimes because the problem is too simple, so it's not interesting. And for me, and I think as Wendy mentioned, I went through a long journey, and from sociologist, and but for my sociology work, I mostly focus on the data analytics side. So, and like when I was a student at Stanford, I have been working working as a TA and RA, and everything is about research methods. At the time it's called research method. But at that time was a long time ago, right? I still remember that with a PC, and you will like upload your data. Then at that time, social science people mostly use SPSS. So you get the program start, then you can go out for lunch. Then even after you come back, then the program is still running. Then you just wait till to come out. So like that's where we start, right? And also at that time, and most people deal with small data. And if you lucky in collecting data, if you get data from a few thousand, it's not like even now like billions. And if you have like data about 5,000 people, at that time was called big data. And it can easily get your PC crashed during the computing. And so you see that is from that's where we start. And also like even because for me, and besides my work, after I graduated from Stanford, I taught to many and PhD candidates, because I have been always talking about the research methods in the social science. So in social science, when we talk about the research, we always follow this pattern. Yeah, it's a process. Because I'm in the data side, right? So I teach people at that time. I taught people about data and about using tools. But the fundamental is still, uh, and we start with the problem, define problem, then select the design. And at that time, like most people will use like a survey to collect data. And so you get the instrument, usually it's questionnaire, and then you go out for data collection. After that, you process data, then do some modeling, then out from, then you get a report. So the process is the one I have been working with and experienced a lot. Then from there, I think because many people ask me like, you're a sociologist, right? Then how you get into the data science field? And because data science field is very hard, and especially according to the article on Harvard Business Review a few years ago, data scientist as the sexiest job in the 21st century, right? And written by Tom Davenport. And he also live in this area, and he just emailed me. He said he cannot come today, but we'll meet some other time. And so when you get into the application side, at that time I found this that this is also very very similar to what we use in social science. You see that data mining, what they start is that business understanding, data business and data understanding. Then they prepare data, then do modeling, then evaluate the model. If the model was good and they gave good results, they will just deploy the model. So this is the process and used in the data mining field or business analytics and many the similar. Then people from here actually is a very well adopted, widely adopted standard for the process in the industry. So now when you move to the data science, then here is the data science process. It's the IBM and now is teaching this to all the people in the IBM and also IBM to IBM's client. And IBM is also working with Open Group, which is another big industrial standard association. They also try to incorporate this and make this as a standard for the data science and the process. I know in the audience, our friend and Hamid is also working on some of the standardization work, right? And so now everybody is trying to make a stand and to adopt a process for data science. So I just like before we start, I get a question about the confusion and the definition of data science. And it's different people and have different opinion or definition of data science. But if you and narrow down, go into the real application, the work, and the process is something that can easily get people to understand. So for me, it's like it's easy to move back and forth from the social science. We can talk about that process from research, and usually most people from perhaps from hypothesis here, if it's not in the social science field or other field, then you go through this process, get the report, or get your research. So then the similar is here that we have the also always starting from the application side is from the business understanding, then goes through this process, get your application or algorithm, whatever you produce, deploy, then get some feedback and continue. So this is the usually and the core that will connect all the things together. Then also for this, we have some tools, right? Like IBM is like SPSS is one of the IBM tools, and now become available, and in the Watson Studio as well. And in terms of the history, I think for people who have worked in this field for a long time, we know that SPSS actually stands for I think a statistical package for social science. That's how it started. But now, like when we talk to the new users about the social and the SPSS, and nobody care about the meaning, right? And so it's just called SPSS. And now it's people call that as a kind of data science software, and which is a part of the IBM Watson Studio, because a few years ago IBM acquired SPS company. So you see, like it's a big journey, like for people in that field, from even some like statistical software, then gradually become now data science. And so it's that journey is not just me. I just happen to be part of that journey, working from social scientist and become a data scientist. And even the tool, right, SPSS, is a tool for a statistical tool for social science, now become and the major tool, one of the major tool for data science. Yeah, I think I just lucky to be happen and can join IBM at the right time, the right place. And in terms of data science, And I, just one more comment before I continue. I know there's a lot of experts in here, and so whenever if you want to raise any question and want to make comment, feel free to do so. And from my past talks, I feel most productive one always that the Q&A and make things also more interesting. So in terms of for, yes.
Just had a question on
Yeah.
so the data mining workflow involves modeling and then going back to business understanding. Why does this new methodology not go back to business understanding?
Here, go back the data understanding back and forth, right? You mean this one?
From modeling. So once you get to the modeling part.
Yeah.
Or
you can also go
even
back
the next part. What does it say there?
Here's
evaluation.
Evaluation, yeah.
That goes back to business understanding.
Yeah.
I'm just wondering why there's no loop back in the new process to business understanding.
So here, right, and not back to the data understanding. That's very good question, and I actually do not have a quick answering to that. I think right now is that one challenge is they want to here complete this process is that currently the train is a little bit different. Is that here and during the older days, I would say, you usually have 4 weeks or even longer to complete a project. And right now here, I think my interpretation for this one is that now you are pushed to complete project in few hours. Okay, so you do not want to from the evaluation, you probably do not want to go back to here, evaluation, go back to business, right? So you do not want to complete this, complete the deploy, then feedback. Then feedback, you will go back to there. And I think mainly is that because the deploy and now is easy, right? And you can get quick feedback. Then rather than here, if you get to deploy and because the computing at that time was very, very slow, then it will take you a long time to finish this. Then here, when you get the deployment, even for SPSS, you need to wait for a few hours. Then here, now is that you can, even a few seconds, you can get here. And so it's better to make that connection. Yeah, I think we can, I think for IBM to get this kind of process, and also other people may have experience, they can talk a lot and then also get pushed, to adopt the current situation. That's my understanding, yeah. Thank you, that's a good question. So in terms of the journey, so the next step, I think we are pushing to, and also a lot of people working on, is about the data science and failure. That's what I mentioned. According to Gartner, it's a very well known and market research company. They estimate 60, depends their report. Some of their report even gave a number of 80. So 60 or 80% of the data science project failed and didn't meet people's expectation. Because right now it's that I also, and after joining IBM and also even before, I gave talks to many places. And whenever I go to university, and especially go to the industrial conference, and almost everybody who talk to me, CEO or the managers, everybody say they have some kind of data science project in their company or in their organization. Everybody does. And but according to this one, majority of them didn't deliver what they initially asked, so become failure. There's a question there. Oh, that's very good point. And what they means and the failure is it's not just complete the process or deliver a report. It's not, and what they meant is that it did not meet the initial expectation or get some problem solved. Yeah, everybody can, like right now, we see in the tools, even amateur, you can just plug the data, then get some algorithm from library, then you get some results. Everybody can do that. Then also with the tools, right now it's most people use a notebook. Yeah, you can just write the comments about your algorithm, then pull that out, then notebook out. You can even produce a report in few minutes. So let's not call the good results. Everybody can do it. And what they means, for example, they said, okay, when they initially start the project, they want to use that data science insight to improve something, their business operation or research or whatever. So if they measure by that goal, most of this failed, or even not. And another measurement they used is that they complete all this process, but then they didn't get deployed. So they just stop here. And so that means you did produce something and some insight, but it's not useful to their business or not useful to the organization. So this, and also we understand in the science field, there is a replication crisis and reported by Nature, right? You have good paper published, but if it's not reproducible and cannot be replicated, it's also almost useless. And I think that one reason, and also, many people worked on to attack this problem, is to take a look of the complexity of the data science. So, if we go back to this field, right, this process, we know that, when you now people do not rely on the survey data because you get data from all kinds of sources. So when you have defined the problem to solve, so when you get the data, there's a lot of options, right? Then how to work to fill in the incomplete, missing data. There's a lot of options. And also how to merge this data together. There's also a lot of options. Then when you merge this data together, there are also many ways for you to handle the identity, right? Because and it looks very simple. There's data, one data here, then another data there, but the identity can be different. For example, in one place, my name is Alex Liu. Another place, maybe just Alex L. dot, or Liu Alex, or and Dr. Alex, or something. And also there are many people named Alex Liu. And so how to solve this? When you get the data together, then also another way is that you will need to choose different kind methods. You want to do logistic regression, or deep learning, or other methods, decision tree, random forest, other options. After you choose that, there's also many other options about the variables you want to choose, right? And also how to even now with other data available, and text data and voice data and video data, how to extract features out of layer. So all this come together, and even for one question, it you can have hundreds options. Then in school, maybe you can have you can spend a few weeks, few months on that. But in the real and the application world, you are often asked to complete everything a few days, the most, and sometimes a few hours. And because of that, I think like there's even you can quickly, easily get some results from a research, but the results can be wrong or biased, and also problems. So after you realize this, then what can you do, right? Because like you definitely have hundreds of options, even for a simple problem. So now, and I think there's many and the solutions proposed, and today I want to discuss is that one solution is with AI, because like for example, for a simple logistic regression, and I also worked with some company who are trying to automate the modeling process, and and for me, I think that's also approach to solve the problem. For example, as soon you get the data, you're satisfied, okay, right? So now, what's the next? Next is that you can choose different model. You can use logistic regression or decision tree or others. Then assume you just want to stick with logistic regression. Then even that, then now you have a big decision. So assume you have 200 variables. Then how do you select those variables, right? Then depends on your criteria and algorithm. They have many ways. Then besides that, then you also need to, sometimes when you combine this variable and take them in, can also improve your model, right? If you do prediction, the prediction rate can be higher. So all this combination then can perhaps, if you want to try offline, maybe 800 or 900 possible models to run, right? Then if you do it with human, then I don't know how long it will take. So like one experiment and also some software we tried. They said, okay, we just take this approach. Assume we are satisfied with this data, and we'll take logistic regression. Then we just try all the possible and the combination of the features and also others, then do some quick, simple and selection. Then you can get 900 models. Then we can let machine to run all these 900 models, right? Then you get the results. Then you can evaluate. Then you can use the confusion matrix. You set criteria. Then you select. Then based on that, then we select about 20 best model. Then after that, then you just after you select this 20, then the next step is also very difficult, right? Difficult to select the best. So then you can use another approach. It's just ensemble them. You do the linear combination of these 20 models. It's one way. Another would be do the weight, right? And so when we actually try this, then the results surprisingly is better than most of the human effort. And so the company, the organization I work with, they even put this into the Gaggle, some of the Gaggle competition. They just use this machine, this method. And so far, like most of the results and their performance is always ranked in like 80% tile net. And it's machine, right? And it's still good. So that means with this AI approach, it has some value there. We cannot ignore, like compared to a person who are familiar with the subject and spend weeks or even longer, then of course you get better results. But still, if you consider this machine can do this in a few minutes or less, then you still be at the 80 percentile, and the level is still good. So that's one way to approach this project. And in terms of the failure reason, like I think this one, the AI part is mostly solve some of the problem, like select we don't have time to go deeper, But mostly many reasons for the failure. One is not enough data, and another is like not the right model. And I think some of you may be familiar with the no free lunch theory. Yeah, which means like if you apply the same optimization algorithm to all the problems, then basically you get the average. Yeah, that means you definitely need to select the right approach. So besides that, we also have taken another approach is to work with the community. And community means like it's similar to it's basically related to uh, the algorithm problem, right? Algorithm problem is that in the reality, in the companies I know, I work with, and most of those people now just quickly hire a few data scientists, 4 people, 5 people, and now like deep learning is hot, so everybody knows the neural network, deep learning, then and then become a common and the issue is that like everybody know, right, when you have a hammer you like you think everything is a nail, right? So you just try to apply the ones they are familiar with, the methods, to all the problem. Then also that's one reason cause so failure projects. And so what we try to do to solve that problem is to create a data science community. So in that way, and then people, when they have problem, they at least can connect to the community, not to rely only the small group who are comfortable with neural network or comfortable with and some kind and decision tree or just the regression. So it's not narrow. So so another like approach we have been working on is called ecosystem and with AI. For the ecosystem, we think at least you have 3 elements. One, you need a data portal. Data portal will allow you to not only access to the handy data you have and master for a long time or access to. And the second is that you need a data science community. And the third is that you need to have a better data science platform. It's not just software, not like many years ago, people just have, okay, SPSS or SAS or something that can be able to handle everything. So with this together, then we think, then you can and work to solve and make things a lot better. No, so like and we also tried this. And one example is that with the cities, like the city of Los Angeles, and I work with a lot. And for this approach, is that you have open data right now, like in the U.S. and the law is required for everybody to the city government, the government to publish everything we collect. So they have a big amount of open data, especially the cities, and they have everything, even the employee salary and about the traffic and about the request. Like every citizen give them call, they need something, it's recorded. And when they call and when this problem gets resolved and how long it take. So all this information. And but then in the city, right? Their resources are also limited, so they need to gain some access to good and good platform and also good community. So we can help them to organize a data science community in Los Angeles. Then so with this data and data science community and some like open source, free and the data tools, then they were able to actually solve a lot of problems. And another one is that we also worked with the IBM weather and data. IBM and acquired the weather company, so it has now a huge amount of weather data and each time point and also location. Then with that, we also like worked together with some, actually the biggest grocery chain here, right? It's all operated by Dale Hayes. Yeah, we work with them, then we get the data and they collect plus some open data, then and also help them to access some small community. And then the IBM and the data platform all these three together also improve the data science success a lot. So all this data community, because a lot of them are available. Then for me, I also specifically create something in Los Angeles, right? And the one I created there is we have a local community in the Pasadena area. We gathered about 1,600 data scientists or data professionals. And then also online and through LinkedIn other places, we also have like 30,000 people and gather together. So those things has been established by many people, including myself. And so we kind of need to get together with the other and the system, then become real good and the ecosystem. And to support this system, you can use the IBM tool, like the one I mentioned, evolved from the data workbench to data science experience, now to the Watson Studio. And besides that, we also, and I myself, and also recently create the RMDS lab. We also have a platform where you can upload your project. Then through that we can help you to connect to more data, so we can do even data recommendation after we understand what you're working on. Then we'll say, oh, this data may be useful to you. Then besides that, we can also help you to connect with other data scientists, so that connect to the community. And then the other data scientists may even offer some peer insights to help your project. And all this together, we think the data science ecosystem approach is slowly emerging and will become something very powerful. And I remember actually I have been one of those person who advocating this ecosystem approach for a long time. And I remember when I first talked about this and in IBM, I have maybe less than people listen to me. Then after a while, and in my last talk inside IBM, and I also got the room which actually can hold 150 people, but totally packed. A lot of people come. So this it really gradually it's become something that people think has some value and can be useful to really attack the problem I mentioned, and the high fail ratio, and also the replication prices, all those things. I understand I need to complete my talk on time, and thank you. And I think we can now open to some questions and comments and advice from anyone. Yeah, thank you. Any question? Yes.
Hello. Thanks so much for the talk, and I appreciate your point about talking about failure. I work in clinical, and appointment of Watson there is to kind of guide clinical decision making. I totally understand everybody's an expert in hindsight and all that, but you're the actual expert, so what do you think we can learn from that? I guess you could call it a failure. It's a failure.
No, actually, this is a very special field, IBM, right? IBM a few years ago pushed out to the medical diagnostics tool, and some people think that can solve and can perhaps replace all the medical doctors, right? Then for some cases, they are actually good and success. For example, I remember in one of the IBM conference, the head of the Tokyo University Medical School came over, and he said for one of the interesting case, and he said even for one cancer, if you print out all this and research paper and technical report and doctor notes and all this, you pile them up, it can be higher than the Fuji mountain, which is the highest in Japan, right? So nobody can really not any single human will be able to process all this. It's impossible. So that's the reason for machine to come in. And he also mentioned in one of the case, and a cancer case, so when it become very difficult in the university, in the school, they will call experts to have a panel discussion to figure out a way, right? But nobody offered any solution, so they basically gave up. Then in that case, they tried Watson. They become because Watson can access all the related reports, then luckily for that case, Watson find one research paper produced by someone in Europe. It's for one or two cases that can be possibly used to solve this problem. So they try and they save that person's life. So there is definitely, for some cases, the AI, the machine, and this can help. But also we see that, right, that at that time, IBM and also others were maybe too optimistic and pushed out a lot. Then I think also caused some problems. Then IBM pulled back. Then even downsize a lot for that part. So you see in this field, and definitely that's the correct direction we have to go. We have to work with AI to really improve the solution and also improve data science. But it's also not that easy. And for my information is that many doctors talked to me and they said it's not that simple because even you get the correct diagnostics, and for this kind of application, because everything is judged by the results, right? So even you get the correct diagnostics and the correct solution, if it's still different in terms of the machine and patient reaction versus the doctor and the patient, because the doctor can sometimes and also help the patient and to comfort them, to give them confidence, and also help other things. So the results is different. The machine cannot incorporate all this information. Yeah, like the psychological and also other information. So that's why still, and we are pushing for this, but still there's a lot of area need human input, and also other things. So I definitely will. Yeah, I think that's a very, very good question, and we need to move forward. But it's still not easy, very complicated. Yeah, simple answer is yeah. Any questions? Well, yes.
Not a specific question, just a category. So many of the data projects that I've seen, especially where there are groups of people coming together, public, private, universities.
Yeah.
There's an issue of who owns the data, and a lot of projects never go anywhere because insurance company X refuses to let university Y use the data, or at least take possession of the data. They can rent it or borrow it.
Yeah.
And I'm just what from a technical perspective, what things have been developed recently that help allow a reasonable way to have people share data without having to give up their perceived ownership. Operations in particular, the ones
Yes.
don't
Yeah.
want to give stuff away. Anyway, so any technical improvements that are on the horizon that it's really sort of needs to be baked into the technology early on for it to be able to develop an ecosystem of tools that work.
Yeah. And yes, this actually is. I'm agree. Yeah, I agree with you. This is a very difficult situation, right? In the past, I worked with many corporations, and especially the banks, insurance companies. They cannot allow you to share any of the data they own, and so when I work with them, I have to even put my IBM machine or other machine away to use their computer to access their system, then to just contribute on their data set. And but there are like many and effort made to push for sharing data, open data. Like the one I mentioned, at least for the government collected now all are open, and the open group I mentioned, they also like and start to pushing for some initiative and to help people share data, especially what they call the pre-processed data. So they are like starting to establish some like standards about the pre-processed data and help people to get a good structure and to share from it, right? Because when you do the sharing data, one and the big issue is about the identity, right? The data you share and the data and the Wendy share maybe completely, maybe cover the same people, but the identity and other things are maybe coded or named differently. So they are trying to establish some kind of standard to help that out. And I also like understand from the companies and Google has a data set search, right? So they're also pushing for more data to be shared and other companies. And actually, and from what I know, is that there are even a lot of like open data available, but the people do not know how to use it. Because recently I worked with NASA JPL, and they have, because we have thousands, right, and satellites surrounding us, and every one of them like now are taking lot of photos. And the computer vision technology become even now like better and better. So with those photos, you can quickly extract some features out, then that can be used for other applications. Now only very few organizations, a few people are taking advantage of this huge amount of data. And so, but now I think there's effort move forward to really like get this and data to be easily shared with other people. So basically, I think I see more and more effort, and yeah, start going to forward to get more data shared. And also, I think another from technical perspective is that there may be, and a lot of technology need to be developed to make the data sharing easier. Yeah. Now it's like one reason people do not use the NASA open data is that it's not easy. Yeah. The data is there, it's not easy to be used. Yeah. Thank you. Yes. They are. I think when the IBM started this, and there are some hospitals adopt this, right? And at that time, I saw a report that said for the common and stuff, then the machine and the doctor are about the same. And but for the difficult ones, actually machine perform better. Yeah, at that time, according to their test. So and so that's why like there's but related to this, there's also a lot of legal issues. So so it's kind of still, and as for IBM, I think it's a push that machine will become assistant to the doctors. Yeah, so the doctor will still need to review the diagnostics recommendation provided by the machine, then make their own decisions. Yeah. Oh, many, a lot of them. Yeah, a lot of them. Yeah, a lot of them then have been implemented a few years ago already. Yeah, many. Yeah, and but now like IBM can, I think, scale it back a little bit, then improve, then we'll push forward. I think definitely is the direction to go, and the human and machine working together, like what the Tokyo hospital heads mentioned, so much information is impossible for a human to be able to process offline. You definitely need some machine help, need some AI. Yeah. Yes. Yeah.
I'm just wondering, like, not having enough data problem.
Yeah, I think the data sharing is one solution if more data can be shared. And not enough data, and I think the problem is more with the technical teams. And currently, then if we put the data restriction side, like because like for example, for the financial data, right, and now you for us probably difficult to gain access, but still you can purchase certain things, and that's the data sharing problem. And what I mentioned, and also by Gartner, other people mentioned about that not enough data is that you actually have and huge amount of data available, enough or more data you can process, but many of these teams they uh, didn't use all of this data for their project, so they get failed and failure high ratio there. And the one reason may be technical because, for example, the NASA produced the satellite data is available there, but nobody has been used them. And weather data is also available. You can purchase from IBM, then IBM's company made that easy to be used, or even you can access through some like open source, yeah, on the open portals. You can get a lot of weather data. And according to many research, that weather data has actually the big impact. And I think partially because I just changed from one weather to another, even to for a lot of things, like even for the advertisement and consumer behavior, and also affect a lot by weather data. But people do not use that much. Then your model become, you know, either biased or less predictable. So for that one, I think the one step for this and the teams is that they need to access, gain control of more data, and they try to utilize them. That will improve their model a lot. Then for the overall, we need to attack the data sharing problem, then get that solved. That make things a lot easier for them. Yeah. Yeah, I'm not familiar with that data, yeah. But I think overall, that's a lot of effort has been made, yeah, to kind of help. And one is that you have the data, and then you have the metadata, right? That can be useful, right? And but back to the early question, I think the uh, uh, interesting part is that you mentioned for some of the projects you do not need the big data, you only need the key data, and that is the common I heard a lot, and also people definitely for people who have experienced in research will always suggest this. And but still is that how do you can extract the key data out from the big data? That's still one issue, right? Then and so for people who comment on this, usually they have worked on this problem for long time, 10 years, 20 years. So basically, when for them, they get the key data is mainly because of their subject knowledge, right? So there is, and but because now it's we can push to make all the your research expertise and insights valuable to all other people. So there's also an effort has been made to figure out a way to best combine the subject knowledge and also the data. So that's a few efforts there. And also the one I mentioned is that you, for you, and of course you can talk to the production people or the data people, and then you get things out based on your conversation and other things because your experience with that. Then, but if we can figure out a way that not rely on and this person's 10 years or 20 years experience rather than on some knowledge and commonly shared, and plus the data knowledge, then plus some algorithm, we can easily, quickly extract key data from the big data. I think that's also valuable. That's the effort and some people are making. Yeah, thank you. Yeah. You by feature and by outcome you means like uh, Q. Oh, okay, the Y, yes. Yeah, 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 yeah. I think this is very great question. And like there are different schools around this, right? Some people, including many teams inside Google, and they don't care and about the why, and they only care as about the results, right? Then whether or not they can predict, and as long as the prediction is good, they don't care about which parameters, even nonsense parameter you used. Then people maybe, I don't care, I don't know, I don't even want to know why, as long as I can improve the prediction. For example, predict how many people who is going to use my product. That's our way. But there are also some people who really push for the why solution, because what they call, they said usually we heard a lot, right? And the correlation is not good enough. We want to looking for causation. And there is one and top expert, and Judy Pearl, his and lab is also working together with us. Then along that line, and there's a lot of algorithms and AI tools are developing. It's not just to improve the prediction or get the correlation, but actually help us to really detect causation from the data. So that's a very important line of work. And also in terms of the interpretation, and also a lot of discussion around that, especially when you use like a neural network or deep learning. You do not know how to interpret, right? You only know, oh, I have good results. Why? I don't know, because it's too complicated. But there is a lot of like forces and effort around that, and especially because like in Europe, they recently passed the law, right? If you and have an algorithm adopt that will affect people's life, then the algorithm has to be interpreted. If you cannot and interpret the results, the law will prohibit you from deploy that method, deploy that algorithm or that model. So like at least in Europe, also a lot of effort and to help people to interpret the model you deployed or you developed. IBM has some tools and also other tools from other companies as well. Yeah, but this is very important direction people are working toward. Yeah, thank you. Any more questions? And if not, I'll just go back to and get back to the Wendy for the stage. And I will definitely stay and a little bit more, and you're welcome to talk to me. Thank you.
Well, let's thank Dr. Liu one more time.
Thank you.
As he had kindly offered that he'll stay a little longer. So for those of you who didn't get the chance to ask question, you're welcome to stay and strike a conversation with him after we conclude our meeting. We have this scheduled to end at 1:30. So we even though apologize for the late start, we managed, thanks to Dr. Liu, managed to end on time. So thank you everyone for coming. Thanks. Have a good evening, afternoon.